Envision embarking on an intergalactic journey, traversing the vast expanse of the galaxy in mere minutes, discovering uncharted realms and diverse civilizations, and venturing boldly into unexplored territories. A vision that has long graced the realms of science fiction and fantasy. Yet the question lingers: could this fantasy truly transcend into reality? Might we one day forge a warp drive, a marvel capable of bending the very fabric of reality, while still adhering to the cosmic constraints? At the heart of this inquiry lies Einstein's theory of relativity, an axiom that proclaims the universal speed limit, the velocity of light, a steadfast 300,000 kilometers per second. Accordingly, the closest star, Proxima Centauri, would remain an arduous 4-year odyssey, while traversing the Milky Way, our celestial home, would demand an astonishing 100,000 years. Within this quest for interstellar travel, an additional challenge rears its head: the phenomenon of time dilation. As we approach relativistic speeds nearing that of light, a peculiar occurrence unfolds. Time decelerates for the moving entity compared to its stationary counterpart. Thus, embarking on such a voyage would cast us into a temporal divergence, causing us to age significantly slower than those anchored on Earth. Upon our return, the chasm of centuries, or even millennia, would stand between us and the world we once knew. Yet might there exist a means to evade these temporal and spatial limits? Could we manipulate the very structure of space-time itself? This notion births the concept of the warp drive, a speculative innovation that envisions altering the geometry of space to foster a bubble of unaltered reality, within which a vessel may traverse at faster-than-light velocities. While it may seem like an artifact from the realms of science fiction, it is, in fact, grounded in the underpinnings of general relativity, the theory of gravity authored by Einstein. The warp drive, a herald of potential progress, constitutes an alternative to traditional rocket propulsion, exploiting the deformation of space-time in proximity to a spacecraft. Although the ship itself remains confined within the bounds of light speed, the surrounding space warps, enabling a leap beyond this threshold. However, the realm of actualization is accompanied by an array of complexities. Foremost among these hurdles are the prerequisites of exotic energies and materials, such as negative energy and negative mass, that defy natural existence. Moreover, the energy required to facilitate this warp dwarfs astronomical proportions, equivalent to the mass of a planet or even a star. Compounding these challenges are the potential emergence of paradoxes and contradictions that transgress the laws of physics, embracing the realms of causality and quantum mechanics. The juncture thus emerges: is the warp drive an implausible reverie, or might a bridge to its realization exist? As we journey through this discourse, we shall delve into the latest advances in warp drive research, navigating the realms of both theory and experimentation. The annals of time have seen theoretical physicists striving to refine Alcubierre's model or craft novel paradigms that circumvent its limitations. In tandem, experimental physicists have fervently probed the implications of warp drive physics, dissecting notions of negative energy and quantum effects. Intriguingly, the frontier of warp drive research spans decades, tracing its path through the corridors of theoretical innovation and empirical inquiry. So, as we embark on this expedition, we shall unravel the tapestry of warp drive's prospects and explore whether the dream of faster-than-light travel shall one day be lifted from the realm of fiction into the realm of scientific reality. This is the Odyssey of Warp Drive, an odyssey that propels us beyond the confines of space and time. One of the most active and dynamic research groups delving into warp drive is NASA's EagleWorks laboratory, under the guidance of Harold Sonny White and his adept team. They have been deeply engrossed in diverse undertakings concerning warp drive technology, including the design of a warp field interferometer engineered to identify minute distortions in spacetime. Further, they have embarked on the creation of a quantum vacuum plasma thruster, potentially capable of generating negative energy. In addition, White's team has put forth a modified rendition of Alcubierre's warp drive, a modification aimed at substantially reducing the energy prerequisites by multiple orders of magnitude. Central to White's innovation is a revised approach to the warp bubble's configuration. The revised shape, more rounded and symmetrical as opposed to the original's flat and elongated form, leads to a diminished requirement for negative energy to initiate the bubble. This alteration also mitigates the demand for exotic matter, which is vital for stabilizing the bubble. However, as with any pioneering concept, White's model is not without its challenges. White postulates that his warp drive has the potential to attain a velocity 10 times that of light, necessitating an energy equivalent of 700 kilograms of mass. This remains substantial, yet significantly more attainable than the monumental energy requisites of Alcubierre's initial concept. Critically, White's model sidesteps certain paradoxes and issues entwined with Alcubierre's framework, notably causality violation and the potential for time travel. White further contends that his warp drive upholds the tenets of causality by strictly preventing signals from being transmitted faster than light, both within and outside the warp bubble. Moreover, White asserts that his warp drive does not yield closed time-like curves, which are intricacies in space-time responsible for enabling time travel. However, White's pioneering model faces scrutiny and skepticism from his fellow physicists. Some argue that his approach still necessitates the elusive negative energy and exotic matter, constructs that remain theoretical and lack empirical grounding. Additionally, concerns are raised regarding how White's model may generate dilemmas within the realm of quantum mechanics, including the horizon problem and the Hawking radiation phenomenon. The horizon problem arises due to the warp bubble's creation of a boundary segregating the interior and exterior realms, resulting in the loss of information that enters the bubble to outside observers, thereby transgressing the conservation principles of quantum mechanics. Conversely, the Hawking radiation problem is rooted in the warp bubble's generation of a region characterized by negative energy density. This leads to the emergence of particle-antiparticle pairs through quantum fluctuations, with one member of the pair being annihilated while the other escapes as radiation. This results in the gradual loss of energy and mass from the warp bubble, accompanied by the emission of potentially detrimental radiation. Despite these hurdles, the pursuit of warp drive technology remains undeterred, with contemporary researchers Alexei Bobrik and Gianni Martir stirring considerable interest through their groundbreaking publication. Their innovative perspective embarks from a broad framework rather than specific models like Alcubierre's or White's. By delineating criteria that a warp drive must satisfy, such as alignment with general relativity, superluminal travel, and the transportation of passengers or cargo, Bobrik and Martir unveil a multitude of novel approaches to warp drive. This innovative approach bypasses the requirement for negative energy and exotic matter, and also sidesteps conflicts with quantum mechanics. Remarkably, their model affords greater flexibility and control over the warp bubble's shape, size, speed, and direction. One captivating implication arising from Bobrik and Martir's work is the prospect of warp drive extending beyond interstellar travel. Speculatively, warp drives could potentially manipulate gravity, spawn artificial gravity fields, or even engender wormholes or interstellar portals. While the future of warp drive remains replete with intricate unknowns and complexities, it is a realm imbued with promise and fascination. As the relentless pursuit of knowledge continues, scientists strive to elucidate the enigma of negative energy and exotic matter, untangle the interplay between warp drive and quantum mechanics, and ultimately gauge the feasibility and practicality of actualizing this revolutionary technology. In this voyage through the intricacies of warp drive, the allure of discovery is undeniable, offering glimpses into realms that may reshape our understanding of space and time. Through the persistent efforts of researchers, new horizons beckon, and the boundary between warp drive's promise and science fiction begins to blur. Your journey into the universe of faster-than-light travel and warp drive technology concludes here. If this exploration captivated your interest, we invite you to show your appreciation by liking, sharing, commenting, and subscribing to our channel, ensuring you stay connected to the marvels of scientific inquiry.